Hello, my name is João Pedro Carvalho de Souza. I'm on my second PhD year on UTAD. My thesis title is Adaptive Grasping Planning, a novel unified and modular grasping pipeline architecture. My supervisors are Professor José Boaventura and Professor Antônio Paulo Moreira, and the associate institutions are UTAD, FEUP, NESCTEC, and FCT, which I have a grant. My presentation is divided as follows. First, I will give a brief context and motivation of my PhD, and then I will present my PhD itself with objectives, schedule, curricular program, and expected implications. Well, context and motivation. Grasp, picking, and handle objects are easily performed by humans. Since we are child, we can perform this task. However, for robots, it's an imperative issue with several practical and industrial applications. This is a challenging task since it involves perception, sense and localize the object, planning, where to grasp, and control, how to execute it. Since we have many applications, we also have several grasp methodologies, which one with its benefits and limitations, applicable in different situations. Basically, we can divide the grasping methods in two main classes, analytical and learning approaches. Analytical methods are based on grasping mathematical modeling of the active pairs. In other words, the robotic hand and the target object. This category normally are very task specific, since the complexity rises according to the assumptions and the generalization needed in the task. Therefore, the results are limited. In other hand, the learning category is based on human capacity to learn and grasp things. Thus, this category is more able to generalize. And when I say generalize, I mean the capability to extrapolate grasps to new objects and gripper shapes. However, it is difficult to describe a good grasp and build enough database. Here we have some learning examples from classification, reinforcement to supervise the learning algorithms. Nowadays, the academic community focuses on the study of reinforcement and supervised algorithms with deep learning policies achieving interesting results. In a special case, to the supervised, since reinforcements are very time and source expensive. In that case, the trial and error learning process limits the result to the database generation. All the methodologies discussed here have its benefits and limitations, and the complete generalization algorithm is not achieved yet. In that point, my first PhD question comes. My main objective is the design of an innovative modular software architecture able to be either modify and reconfigure, giving support to the following methods. In that way, we can speed up the configuration and setup of grasping deployment. In other words, the user can develop, the user and the developer only will need to pick methodologies, set up some parameters, and test in a faster way. My second PhD question is regarding how improve the generalization performance. How improve the grasping description to be able to be more generic. For instance, the image classification grasping modeling achieve interesting grasping detection success rate. But when these techniques are used in real case, the success rate are not verified. This led us that grasping is more than a region classification problem. So my second goal is to contribute in new grasping description, improve the already grasping database, and generalization capability. I'm looking to include gripper model generalization since it's not widely explored in current literature, which focus is on two fingers and Sukesh gripper model. This is important since in industry we have several models of a gripper structure. This is my thesis plan. Basically, This is my thesis plan schedule. Basically, and in a summary, it can be split in 5 tasks. The first one is regarding the study of state of the art that I finished. The second one already started, is regarding the design of my software architecture and the evaluation of tools methodologies. Thus, I pretend to propose my new generation and grasp description and task 3. Find the test and the thesis written will be performed at the last task, at the last 2 tasks. Task 1, it's already finished, as I already told. The outputs were a journal survey and a conference sensors evaluation publication. Task 2, this task is still in progress, as I already told. I already published 1 journal paper and give contributions to R&D projects, such as Fasten, Scalable, and Adapt Tech that we have in our lab. Now I'm working in a mimic grasping solution. Here we have some pipeline architectures that I propose in this current task, task 2, okay? I'm not going giving you some specific entries about that, but you feel free to contact me to any questions, okay? And let's explain a little bit about, more about task 3. This task will be start in this year. I'm looking to publish a journal paper and add a machine learning solution to my pipeline. Here we have the task 4, where I verificate and validation my pipelines. It's already begun since I was part of different R&D projects. Thus, we can see the test in these videos. Let me start them so you can check. Here we have some solutions that I deploy already, okay? The first video we have a real robot perform beam pick tasks using my pipeline of grasping. Here in the middle, we have a grasping generation solution, automatic generation, using simulated annealing and grasp it simulator. And at the right, we have some solutions regarding the translator architecture, so we can deploy in different solutions of commercial robots. Okay. Regarding the curricular program, I already finished. These are the concluded subjects. The first one is Algoritmos e Sistemas de Inspiração Biológica e Natural, by Professor Eduardo Pires. The second one is Métodos de Otimização e Classificação by Professor Paulo Oliveira. The third one is regarding Controle Avançado de Processos by José Boaventura Cunha. And the fourth one is Processamento de Imagem e Visão por Computador, Professor Vitor Felipe. I already performed an external UC, external share, called Publon's Practical Peer Review course. So that's the finish of my presentation. Feel free to contact me for any questions. These are my references, and thank you.